Okay, the problem 3.6.20 is talking about the rational zero, sometimes called the rational root theorem. And when you're working with this rational zero or root theorem, what it is they have proven that if you're going to find any of your zeros, let's just go back to something that would maybe be simpler to look at. If I said x squared minus 2x plus 4, so your only factors you have to worry about here are the factors of this 4 in this place. So it's either x plus or minus 1, an x plus or minus 2, or an x plus or minus 4. So if that's the case, your zeros here, only options are positive and negative 1, positive and negative 2, or positive and negative 4. But all of these are factors of this number. And then they go on and say, well, if you have a coefficient out in front, so if I put a 2 here, then I also have to divide by that 2 when I set this equal to 0 and solve. So then I also can have 1/2 here. If I divide by 2 here, just be a 1. This isn't going to add any because we already had it covered here. But then over here, this 4 over 2 wouldn't add anything either. But what if this number out here were a 6? Now you got to divide them all by a 2, you got to divide them all by a 3, you got to divide them all by a 6. All the different factors of this also have to go there. So go back to our problem. We have a negative 8 here. So we could have a positive or negative 1, a positive or negative 2, all the factors of 8, positive or negative 4, positive or negative 8. We do not have any coefficient out here, so we don't have to divide by anything to solve any of these, but these would just be well, you can put them all over 1, I guess, if you want, but that would give you the correct answer then for the rational zero or the rational root theorem for that to be part C right there on question 3.6.20.